So here's my prototype of the Spinal battery. This is a fully centralized system. It has redundancies, safety fallbacks, and is capable of delivering large currents to peripherals like the ejectable or retractable Batman gauntlets that I designed. Never gets old. So for those not familiar, a peripheral is just a device. So this could be a motor, it could be a sensor, it could be a solenoid like with what I've got here. Doesn't really matter, it's just a device that's going to require power that's going to be a peripheral to that main system, which is what this will be powering. So if you didn't have a centralized power supply, you'd have to have batteries on each device individually, which one, that's awkward because you're adding more weight to awkward spots potentially. But the other problem is having more points to recharge your batteries, right? If you have a bunch of batteries all over, that's a lot of different places to charge up every time that you've used something. And then additionally, the larger problem is that if I needed something like this guy, this is a solenoid that draws a lot of power for a short moment, but to have a battery that could supply that, I'd have to have a pretty big battery, which would be quite clunky. It would make this big, awkward to move, and vulnerable. So this power supply is, of course, near my center of mass, so it's a lot easier to move with this on. It's easier to protect this right here. I can put more heavy armor on it and things like that because it's on my back. So by having this one device as well, I'm allowed to have a lot of different redundancies, different chips in here to make sure that the central power source can be damaged. It'll switch power to the other columns, whatever it needs to do, where you might not be able to do all of that logic in every single battery you'd be putting around your suit. So this little control PCB circuit board back here, which is made by PCBWay, is my regulation chip. It basically supplies a regulated 5-volt power supply for certain peripherals that need that if they don't want to run off of the typical 12 or 14 volt power. And it also splits the power so I can run it off more easily to other peripherals. So it's kind of like a power bus, but I have to have other circuitry in here like my dual power diodes, fuses and things in different spots, which basically I'll have a future chip that will be able to handle all of that. Now, no doubt there'll be questions on the arc reactor. This is, of course, not powering the suit. I designed this a couple years ago. I just wanted to show it off. And it also gives an example of a peripheral again. So this is just a device that I could plug into this guy back here to have it power, just like it powers my actual Batman blades here. So the Batman suit is not going to have an arc reactor. I'm trying to have everything in the suit be actually functional, as this is my interpretation of what an actual functional bat suit in the real world would look like. So now onto the actual cellular composition. So by now I'm sure that you're thinking, can these just explode? Are they gonna combust if you damage one of them? The answer is no. So lithium ion is the typical battery source that we use for our cell phones. Electric cars use them. They have phenomenal energy density, but they are prone to combust, can absolutely explode, and they're very dangerous. So I didn't want to actually strap that to my back. So these are actually lithium iron phosphate cells. They're 50% lighter than lithium ion, making them fantastic for a wearable. Doesn't weigh nearly as much, and it's literally incombustible. These cannot catch fire. You can damage them, puncture them, whatever. It's not going to pose a threat to the wearer. Now on top of this, they can actually be discharged to 100% as well, which is huge. So a lithium ion, you can't do that. It'll actually damage the battery. But by discharging 100%, what I mean is if you take a battery that's 12 volt battery, fully charged, it might be 12.8 or 13.2 or something. And when it's dead, it's actually like 11.8 or along those lines. Voltages are not constant on batteries. They're always going up to down. Now, full discharge would be bringing this cell to almost zero. But the lithium ion phosphate composition actually allows these to go all the way down, and you can recharge them all the way back up. And then on top of that, these tend to have 4 to 5 times the lifespan of a lithium ion battery. The only trade-off is they're slightly less energy dense, which is totally fine. So this is the clear winner for battery chemistry for a wearable power system. So one thing that's important about that 100% discharge, if I wanted critical safety systems, sensors, or other devices to run well below this thing's dead system capacity, I totally could. So I could have systems that run on 5 or 6 volts that could continue to run even after all of the other devices that require 12 or 10 volts have been totally dropped offline. So I could again have those critical safety systems that run on lower voltages run for days on end and not harm the batteries by letting them run on it. So the whole point of a Batman suit is it has to be for combat. It has to be able to take damage, has to be strong, so we could easily put armor on these to protect these. I picked circular based cells and not flat ones because a circular cell, no matter what angle you hit them at, it's distributed evenly, where a flat surface, of course, if you were to hit it in the middle, it's much weaker there than at the ends. And then regarding the redundancy, one column of these could completely drop offline. This could be direct damage, it could be a broken wire, it could be even worse, a short. But the peripherals will see no difference in voltage. They'll be able to continue running as normally because the other will seamlessly take over the power supply for the system. I do have this automotive heavy diode back here that's a dual split diode, and essentially that's preventing both streams of current from being able to go the other direction back into the other cell set. So the cells are totally isolated until outside that diode where they've been merged. And that's where you're able to get that steady power of 14 volts to all your peripherals. The only difference is that the max power output of this thing is about 14 amps in full capacity. If you were to drop one of those columns totally offline, then you'd basically have a max current draw of 7 amps. So what that would mean in practice, if I had other peripherals, let's say a grappling hook or something that took a lot of power, it might not be able to run on its own, or it might not be able to run with other peripherals also consuming a lot of energy, like if I was using the activating both solenoids on both blades and firing some other mechanism, then you might see the current get saturated from that one cell and then the system bottom out. But regardless, this will do its best to make sure that all your systems are powered. Even with half of it being totally destroyed, it continues operating as normally as possible. And then of course I did sew up this harness here. I was actually originally making multiple degree of freedom hinges that would connect each cell together because the thoracic spine, the upper portion, has fairly limited flexibility. But then I started thinking, like, a strap is even more flexible, more comfortable, and it can take hundreds of pounds, like if you get military nylon. So I decided just to strap them all to that so that it's quite flexible. And nylon, of course, is impact resistant. So with nylon, if you hit it with a hammer or slash it where it doesn't cut all the way through, it's gonna continue to behave totally normally for a system like this. Whereas if you had a hinge, then you smashed it, it might impinge the hinge from actually moving and cause other issues. So I decided just to go with sewing because that is a lot stronger there. And again, it does provide for a lot of natural motion, and this battery set is extremely light, so it really doesn't feel like I'm wearing anything back there. I could easily run, jump, do flips, whatever, and it's not gonna get in the way of that. Now I do have prototype version number 2 already well in the works. I've got a lot of designs and things built for that. I've revamped the 3D models so that they've got stronger strap support and other details in here for cable management and ensuring that this system is more organized, and places for fuses and other things like that for, again, more redundancy and safety. Additionally, I've combined all the electronics in here into a single PCB, which is currently being manufactured by PCBWay as we speak. So if you have your own circuit boards and things like that, and you want to do what I'm doing with them, I recommend going through PCBWay because they're always who I go through. They're fast, they're cheap. So if you want to bring some of your circuits to life, I recommend going through them. So do click the subscribe button if you want to see my version 2 when I finish that. It's got a lot of exciting updates and is made to look a lot more aggressive and polished than this current model is. And the next best way to support my channel for free is to just leave a like below or drop a comment. I love reading your guys' comments. I have email notifications set up so I can read every single one, whether it's a question or a comment on something or asking for a future project that I should look at or research. Always appreciate you guys' responses. This is an active community and I appreciate you being here. So with that, I'll see you guys in my next video, which will be version 2 of this Spinal battery.